Hi, everybody. I started coming to Lviv in 2013, and I absolutely love it here, love Ukraine, so I'm very excited. This is my first IT arena, both attending and speaking, it's a great honor to try to talk to you guys today. The title of my presentation is Hacking Humanity, kind of keeping in the theme with this conference, but I want to start with a premise. I think it's safe for us to assume that as technologists, our job is not actually to write code. It's not just that. We are solvers of problems. So what happens is businesses hire programmers to come up with solutions to problems that they have. So if that business could just go and buy the software off the shelf, they would. It's easier, probably less expensive. So they hire us as technologists and programmers to try to solve problems for them. So what I'm going to talk about today is using A/B testing so that you can build software that will help those businesses solve problems, particularly on the web and internet-based. So lots of these businesses have one thing in common, and that is they're trying to generate more revenue, right? Most companies want to make more money and become bigger companies. So as a software engineer, when I come on board, many of the problems that I'm trying to solve, particularly in the e-commerce space or when you sell things online, is to try to generate more revenue, right? But first, I'll talk a little bit about me. So my wife refers to me as the house bear. That's why I have that there. Now, I tried to come up with a good Ukrainian translation for that, but it either was coming out as I was a pet bear or I was the bear of a bear house. So I couldn't do it very well, but that's why that's there. As was mentioned, I started programming in the late 1990s. So I've been doing this for a while. I've built web applications that have served billions of page views. I even worked on a website with MSN that did 1 billion page views in a month once. And I've built applications and websites that have served millions and millions of paying customers. So I've worked at large web scale, and I've worked on smaller things in my own company. Couple of nerd facts about me. The first programming language I ever worked in was called Logo. It was on a Apple IIgs. That was in 1985. My elementary school had one. And the first time I got a paycheck programming was in 1999. So I often say that that's when I became a professional programmer, is when someone paid you to do it, right? So first off, a quick warning. Explaining technology can be very hard. And I know for lots of people in this room, English isn't your first language. So if I'm speaking too fast, or I'm really starting to lose you, just put an arm up, and I'll slow down and try to reiterate or re-explain anything that I can in the time that I have available. So for comedic effect, there's a quick video I want to play. It's from the internet, and this is an example of someone trying to explain Bitcoin poorly.
So basically, there are these things called miners. And so the miners are computers. You plug your computer into the wall socket, and your computer does math. No, you can't really hold them. They're actually inside the computer on this thing called a blockchain. Blockchain. Block is the things of the miners. Chain is what makes them all into one thing. What part of this doesn't make sense? I'm trying to explain it to you. There's a block, and there's a chain, and there's a computer that mines Bitcoins. No, you can't hold them, but it's in the internet of things. It's part of the blockchain, and you can spend it. There's math and computers, and then that makes a coin. Yeah, you can buy things like other cryptocurrencies with it. No, they don't do anything, but that doesn't matter. Can't actually spend it, but I'm just trying to say, if you want to be rich, you can put your money in Bitcoin, and then you'll be rich. It's not that hard. No, I'm not yelling, you're yelling. Just buy it, okay? Where the fuck is our waiter?
So I'm going to try to do a better job today than him. But I am going to be covering a lot of things that individually themselves I could easily speak an hour about. I could even teach a university course on, and I'm going to talk about a lot of them very fast. So my only hope today is that you leave this room and go look up some of these concepts and try to learn more about them and use them in your programming life. So for the agenda today, I'm going to talk about 3 concepts: building, measuring, and learning. Right? Building, how to build and design your A/B experiment. Measuring, how do you analyze and understand the data from those A/B experiments. And how you can make smart, intelligent decisions based upon that data inside of your organization. So that build, measure, learn flywheel comes from a concept called the lean startup, which was written by that guy over there on the right, Eric Rice. He codified this methodology, and the lean startup itself is a big framework for businesses to learn how to basically use scientific approach to learning and deploying software and trying to build up their business. It's a framework, a larger framework, and inside of it is the concept of build, measure, learn. I'm going to use A/B testing inside of the build, measure, learn framework, so we're going to get just a very small part of this, but it is from the lean startup. A simpler way for us to think about this is you have a great idea for improving your existing product, so you code and launch your new idea to do it in a way that lets you decide whether it's going to give you the best value or not. That's the A/B test portion. Lets you measure the results and then analyze those results after the fact. And I'm going to spend most of my talk talking about the software involved in the process of the measurement aspect here. But let's not get ahead of ourselves. What is an A/B test? Let's first define that. So our old development process that many of you have probably encountered in your software development career, someone has an idea, they go up to their UX person, they mock it up, the UX person then has a second mock-up. You guys go back and forth for a little while trying to determine what the best thing is to do. Perhaps then you kind of prototype something. And then eventually it gets to engineering and you actually start doing the programming. You build the concept. It finally ships to the world. Can anybody tell me what actor is missing from this? Right, the user, the customer. And that's actually who we're building our software for. We're not building it for us. But in this process, we spent a lot of time. It felt like we were moving forward. We spent a lot of time designing and developing software, and by the time it finally ships to that user, it can fall flat on its face. So I want to introduce the concept of A/B testing. And one of the core reasons why we employ this concept in how we build and deliver our software is to try to figure out if what we're doing actually is going to work with that user, with that customer. So A/B testing splits traffic 50-50 or some percentage between a control and a variation. A/B split testing it's a new term for an old technique called controlled experimentation or randomized controlled trial. And that's it for right now. Let's just stick with that as a definition. We're going to get into more detail. But the idea is basically that we can have 2 different things that we want to test. So let's pretend for a moment that you're a developer and you're working at a company that specializes in selling widgets on your website. And widget sales have not necessarily been bad, but they could always be better. And your development team has been charged with increasing sales by 10%. So in this scenario, let's pretend your company was working the old way like I discussed before. You would decide what was going to increase sales by 10%. You'd spend a lot of time in that cycle designing that software, deploying that software, and then when you launched it and it didn't work, you'd wasted a lot of time. So there's nothing more expensive than doing the wrong thing. Sometimes it's even better to sit still. And so instead, what you could do is come up with a variation and try to do something very early and learn quickly and find out whether or not it's going to work. And you do this by coming up with a goal, right? So, whoops. And a goal really can be anything. It could be enticing the user to give you an email. It could be getting them to move on to another step on your website or in your application. It could be getting them to buy something else on their website. But the idea is that you have 2 different variations and a goal that you're trying to measure. But it's more difficult than that. It's not quite that simple. There's a lot of caveats. 1, you need to compare variations to a baseline. You need to know what you're going to measure, right? We can't improve upon the things that we can't measure. So you can't, for instance, have an existing website, create new variations, and just test those because you don't know which one's actually performing better against something previous. Another concept, you need to show the same version to the same customer. So think about it. Imagine for a moment that you have a customer that comes to a landing page on your website, and then they leave. They do some other stuff on the internet, they come back, and then they see another variation, and then they perform the action that gets them to the goal. Which variation got them there? Was it the first one, or was it the second one? Know your visitor counts needed to make a decision. So this has to do with determining sample size. How many customers or users that come to your website do you need in order to make a smart decision? You probably wouldn't do it based off 3 users, but is 100 enough? 1,000? It depends on what you're trying to measure. Is the difference even big enough to count as something you've measured? So is 8.1% that different from 8%? Or are you in a zone of statistical insignificance where making the decision, you really can't, you don't know? All of these things need to be managed. So for instance, showing the same version to the same customer is often done with a cookie, but if you were to build something from scratch, you'd have to account for all of this. And what I'm going to talk about today is a lot of the different softwares that you can use that will do this for you, because it can get even worse. So this problem gets much more complicated when we move on from A/B and we move to what we call A/B-N variation tests. Now, you can run things that are called multivariate tests, multi-arm bandit tests, and you can, it gets very complicated, and I'm not going to talk about those other types of tests today. We're just going to talk about A/B tests, but just be aware that there's a whole world out there, an ecosphere of lots of different types of tests to determine whether you're driving a user behavior or not. All right, so let's get back on the theme of the conference and the title of my presentation, How to Hack Humans. So now that we've got a definition for what A/B tests are, who are we actually building these A/B tests for? That's right, humans, right? Ultimately, the purpose of the tests we're trying to design are to elicit a human response. We want a real user who's using our application or our website to do something, right? It's important for us to realize that we're actually already being hacked, okay? It's happening to you right now, this morning, I'm sure. Facebook, Google, Instagram, YouTube, WhatsApp, just about any video game you've ever played is employing these concepts. So what I'm going to talk about today are actually things that are heavily documented, and lots of the big companies are already fully aware of this. This isn't cutting edge necessarily. It's a science that's been well researched. So much of my section I'm going to talk about, I'm going to pull from 2 major books. One is called Hooked by a guy named Nir Haral, and the other is from a book written by B.J. Fogg. There's other ones like Nudge and Thinking Fast and Slow, and I suggest you look at those books because everything that I'm talking about is well documented in there. But I just want to be upfront. These aren't my ideas. I'm presenting science today for you guys that's pretty well established. All the big players in Silicon Valley, where I'm from, employ these concepts on their website every single day. In fact, a couple weeks ago, I heard from a test manager at Airbnb, and they said they like to do about 2 tests per month per developer head. So Airbnb is doing hundreds of A/B tests per month to try to figure out how to drive user behavior. This is B.J. Fogg. So he's a behavioral scientist, and he serves as the founder and director of Behavior Design Lab at Stanford University. And since the 1990s, he studied and proved that you can alter people's thoughts and behaviors through the use of computers in a highly predictable way. And that's really what we're looking for inside of that build, measure, learn A/B testing framework, is can we predict that we're going to build software that will actually make a difference, right? We want to be smart about the code that we're going to write. So in 2009, he published a concept that became fairly renowned around the world in both business and public health sectors for analyzing these human behaviors. I'm going to talk a little bit about this right now. This is the model he invented. It's called the Fogg behavior model. So Fogg posits that for any human behavior, B, to happen, you need to have motivation, M, ability, A, that means how difficult or easy it is to do something, or a trigger, sometimes called a prompt. You'll even see me refer to it as a prompt later here. And without the sufficient MAT, you're not going to get that user to change their behavior. In effect, they won't do the thing you want them to do. Let's dive into these briefly. Getting any person, or in our case, a user, to perform a behavior, they need to have sufficient motivation. How much energy for action does that user have? So Fogg posits that it comes down to several factors, but in general, people will seek pleasure and avoid pain. They will seek social acceptance, and they will try to avoid social rejection. So think about the marketing line that I'm sure you've seen on websites. You don't want to miss out on this. That's actually playing to the human emotion to not want to be socially rejected. The concept of not wanting to miss out on something means I want to be part of the in crowd. So that's a play on the motivation to increase a user's motivation to do something. Second is the ability. How easy or difficult is it for that user to perform that action? This is pretty straightforward for us, right? So if you make a user do a lot of steps on your website in order to accomplish something, there's a decent chance that you're going to reduce the number of users who are going to perform that. We often refer to this as friction, right? So what is your friction in your website for a user to perform something? And then finally, the prompt. So these are the things that cue a person to what they're supposed to do. Press A to play. Share this on your Twitter timeline. It's the thing that tells the user exactly what they need to do. So again, B equals M plus A plus T. So now that we've covered what an A/B test is and how to think about driving user behavior, let's get into how we could actually design a good A/B test. There are 6 primary steps to designing an A/B test. And this goes for anybody in technology, whether you're a developer or a product owner, this is the same process, right? 1, you need to collect data. So this is what I talked about before. If you don't have a baseline, you don't know what you're going to go after. So if you're running a website, you probably want to know how many users visit your website. Where do they go? What are they currently doing, right? Because you need to know what behavior you want to improve upon. Identify goals. So that's, as I talked about before, that could be any sort of step that you think you want to do on the website. Drive conversion rate increase, etc. Get them to go on to another page. Get them to log in again. Form a hypothesis. So looking at your data, you could say, based off what I see here, I'm not seeing users doing the thing that I want them to do. So I think that if I program my website in such a way that I'll get that better behavior, right? 4, create variations. This is the coding part, right? We need to actually code what we are going to be able to test. And notice that if you start at step 4 and you don't do the first 3, you're not being very smart about your programming. You could be wasting your time. You could be spending time building a thing that you think is beautiful, but you haven't actually even started to involve the user yet because you haven't looked at that data. 5, you need to run the experiment. So once you have your thing coded, you need to get out there live, right? You need to be able to start gathering data to find out whether what you're doing is correct or not. And then finally, once your experiment reaches to sample size, you need to analyze the results. If you're not learning from what you're testing, then the whole process also is for naught. So let's design an A/B test. We're going to use our hypothetical from earlier where I said we were pretending we were developers working at WidgetCo. And we're asked to create a test for our credit card page that'll help us generate some new sales. We know that this means we need to think about creating an A/B test, so let's get started on that. So first off, we need to consider what goal we're going to be going after. That's that step 1 and step 2 I just mentioned in the previous slide. You can't really use a qualitative goal. Things like, I don't like the site because it looks old, or that font stinks, or I just don't like the appearance of our website is very difficult to measure generally. So you need to try to come up with a quantitative goal, something that you can measure. So in our case, we'll say only 8% of our customers who come to our credit card page actually buy a widget at WidgetCo. So if our goal was to increase sales by 20%, that would mean that, let's say, for every 100,000 users who came to the website, 8,000 would buy. So if we wanted to increase it by 20%, that means on the average, we'd want 9,600 customers to convert, right? So your goal would be, I think I'm going to program a variation that will drive that amount of business. So now that we have our first sets of steps where we've gathered our data and we've formed a hypothesis, now we need to form a hypothesis. So if we go back to our model of B equals M plus A plus T, we're gonna suspect that we can't really take form fields off our credit card page because we need all of that data in order to process the payment. So we're gonna try to find a way to increase the user's motivation in order to get them to buy more. So we meet with our UX people and we start talking and they go, hey, I saw at a website where there was a timer on the credit card page. Actually, I see this a lot of different places. Turns out lots of websites use timers. What they're doing is, again, tapping into that human emotion, that response that you don't want to be missing out, social acceptance. So our hypothesis is if we change our credit card page to increase the user's motivation to buy, then we could see the increase in sales. So now we have our hypothesis, our data gathered, and we're ready to start coding. So our new development process, we brainstormed ahead of time with all of our partners in the business we work for. We looked at the data. We came up with the idea about what we want to change on the credit card page. But what needs to happen next? What's the next step in our build, measure, learn? Well, we need to code the thing, right? So let's talk about the software that we can use for actually building and deploying our A/B test code. So there are a lot of them out there today. I'm not going to talk about the statistical math involved in A/B testing today because I just don't have time in determining sample sizes. There's calculators. The information is easily found online. I think the most important thing for you to take away today is there's a ton of open source projects and commercial offerings. There's lots of websites out there for apps and just about anything that you want to do on the web that will help you construct your A/B tests. Look there first. I highly suggest Google Optimize to this group because it's free for everyone in this room. But Google knows this stuff extremely well. But there are others. So Optimizely is another big one. I have a lot of experience with this product. We used it for a number of years before it became cost prohibitive for our business. The reason is Optimizely's business model, they charge you more based off the amount of traffic you have at your website. So if you end up being really popular, you're going to either pay them a lot of money or you're going to come up with a different software. A/B Tasty is another, Adobe Target, SiteSpec, VWO, Quibbit, Sentient Ascend. There are literally dozens of offerings. But what do these have in common? A large similarity for them is that most of these A/B testing systems work off what we call client-side code injection vehicles. So what this means is if you're building a website or a web page, you have all of your HTML and CSS being served on that page. What most of these systems do, not all of them, there are some that are server-side and some that are self-hosted, but how a lot of them work is you write your JavaScript code or you write your website code and you give it to them and they inject it on top of your existing HTML page. So what happens is with that little snippet that you include, which brings over all of your experiment code, it does the randomization, it assigns a variation, it cookies the user, and then your page paints and then they either get a variation or they don't. So how does that actually work? Well, let's talk a little bit about how browsers work, right? So if we have a page that renders that comes from my company at JustAnswer, we have these landing pages that we use for direct marketing. The browser parses the HTML, it loads CSS, it parses CSS, creates the DOM tree, and then eventually it displays to the users. Browsers are obviously really good at eating junk, but they're also very good at processing it. But the end goal is a render. So again, text converted into objects. Those objects are understood by the browser and then eventually rendered, right? So it builds your DOM tree. In these client-side testing approaches with A/B testing, it actually forces the browser to do things twice. So for my web developers in the audience who think a lot about where they place JavaScript, if you put experiment code in the header, it becomes a blocking call. If I put it in the footer, it basically becomes a delayed or a lazy kind of response. So it's no longer blocking, but what will happen is you render your first page, that experiment code kicks in, and it re-renders again. So the way a lot of these A/B testing concepts work may or may not be a big issue for you, but it could be because at our business, we work at large scale. So we're serving millions of pages to millions of users, and a few seconds of added time or a perceived issue for the user will cost us lots of money. So some A/B tests can be very noticeable. The user requests something, and then when the experiment overwrites it, it's pretty visible, right? This is my niece, by the way. When that browser repaints that new experience on top of it, the customer might be deterred from trying to do the thing that you want to do. This is fundamental to the system. There's not really a way around this fact. This is how browsers currently work, and this is how code is currently served if you take this approach. There's other ways to do A/B testing, but since so many of them work that way, I just wanted to talk about that. We call it a flicker. So when that user sees one thing and then the experiment rewrites over on top of their browser, they have a perception of a flicker. There's not really a way to fix that flicker if you use that client-side injection approach. There's no hack a team could do. Oops. It's inherent to the system. And the reason is client-side test code injection is a Kanye West interruption to user experience. So for those of you who don't know or don't remember, because it was years ago, Taylor Swift was at the MTV Music Video Awards, was accepting her reward, and Kanye got up on the stage and said, "I'm going to let you finish, but I want to say something first." So the user starts to get Taylor Swift, but then eventually gets Kanye. And that's because it's just layers. We're basically layering experiences. As long as you're serving layers in a test and using this approach, that's what it's going to be. So if it's so bad, I've been just talking bad about it for so long, why do people use client-side code injection for A/B testing at all? Well, because it's fine for minor UI changes, right? So let's take a look at Taylor's eyes and lips. All right, so I'm just changing her color there. If I was doing an A/B split test off which customers prefer Taylor's eyes blue or green, it would be fine. Where you run into problems is when you start blowing out the DOM in a major way. Right. So I'm going to talk a little bit about an advanced alternative that I worked on, that we built at JustAnswer. It was a great experience, but I just want you to know that there's other options out there so you can be thinking about server-side approaches to A/B testing, especially when you're working at scale. So we built something that we call Revisely 2.0. The reason why it was 2.0 was the 1.0 version was basically a client-side injection approach, like I just talked about. We just didn't want to pay Optimizely anymore and built our own, and then we kept building on the concept. So some highlights of what the technology actually did. So there was no flicker like I talked about. We were just giving one experience to the user or another. There's no need to code twice. Now what I mean by that is your A/B test, you could be writing in a JavaScript. Let's say that test wins. Making that code normal, meaning that becomes the experience that the standard experience, the control experience that your users generally get, could require you doing some different level of coding or different type of coding. There's no need for users' browser to repaint because they just get one experience. It also was much faster, so it removed that concept of layers, and it leveraged all of our pre-existing analytics. And the reason was we built it on top of an edge computing concept that the CDN Cloudflare now offers called workers, or worker processes. So Cloudflare has 179 data centers globally. You deploy your code to one location, and it automatically goes out to all of their data centers. So I'm going to talk a little bit about why that's exciting, but this is what we basically did. We built an A/B test engine code in TypeScript that transpiled to JavaScript that deployed to the CDN and matriculated globally. So let's talk briefly how a CDN works, for those of you who aren't aware. They're generally used to minimize the distance, the geographic distance, between users and the requesting server, right? So JustAnswer servers are primarily in Chicago. In Ukraine, if you're making a request to a server in Chicago, there actually is going to be an expense to that. There's going to be a cost, right? It could be a couple seconds. Whereas if you reach a cached server in Germany, it's going to be much faster for users here, probably a second or less. So the basics. A client request comes into Cloudflare, the CDN, who's offering this. And by the way, there's other edge computing offerings out there. We just decided to use Cloudflare, and I'm just speaking from my experience today. The CDN matches it to the closest person to where they are on planet Earth. We have a lot of customers in Australia, so not having them make requests directly to Chicago and request a CDN in Australia actually was a very big deal for us. The test assignment runs at the CDN and not in the user's browser, right? So when that HTTP request comes into the CDN and hits that engine code, we break apart the HTTP request. We look and see whether they're on an experiment or not. We have a set of JSON rules that we can update that the engine code can read, determines whether that user is eligible for the experiment, assigns a cookie to them, and then gives them a cached version or route of the experience we want them to have. So all of that's happening lightning quick at the CDN. And since the test variation is already cached, it doesn't even have to come back to our servers in Chicago. It's just going from the server that's close to them again. So the user just gets the test experience instantly. And we don't have that flicker. And no performance woes. So this is an example of a web page test where we had a control versus our cache version of the CDN. It's not doing anything other than just showing the same version of the same page. So you can see that it paints faster from the cache version than from our control. And this has to do with one reason. Whoops. The speed of light sucks. I was in San Francisco making the request on the control version to Chicago, and then the test variation was making a call to a CDN in San Francisco, and that actually was giving us half a second difference for the same exact page that wasn't even doing anything. So geographic distance can have an impact. And the trick is that means we have all test variations in cache, and it's just a matter of serving one, right? So instead of layering things on top of each other, we just have all the experiences that we want to have available to the user, and then we just decide how to route them. All right, so I talked about how to build an A/B test and how we built an advanced one that was doing A/B tests. We were gathering lots of data. Okay, how does an organization learn? So one of the things that we learned at JustAnswer is that if you can do the building and measuring well, and you can launch the code well and gather data well, but if you're not communicating well as an organization about what you're doing, and you're not learning, you're not going to get better, and your business is going to hurt itself or not be as successful as it could be. So we make our learnings public, well, public internally, right? So it's not something that's hoarded by engineering or hoarded by product. We all meet and we talk about the different experiments, what the results were, and everyone can hypothesize about what they think is happening. We try to be data-driven, and we think that that's what most businesses should be doing with their engineering groups, right? So everyone should be breathing and thinking and talking data. So we decided to do a big experiment. It was very audacious. This was Q3 of last year. We wanted a new landing page that was completely different. So graphically, it was very intensive and very different. We wanted our users to communicate with our new chatbot as the primary call to action, and we wanted to increase engagement with her. And we needed our page to be highly configurable. So we have a component-based web page. We wanted to easily be able to switch out those components and do different things. So this is what the old page looked like, right? So it's kind of smushed in there. And we did have a chatbot, but there was other things going on that we felt were drawing the user's attention away from doing things. So in this case, our hypothesis was the page was too busy. It was letting the users click on different things. We wanted to drive that user behavior to communicate with our chatbot, right? So that was our hypothesis. So this is what the new UI looked like, right? So we put together the web page, we looked at it, and we're like, yeah, this is great. We think that this page, and by the way, we're talking weeks of development effort, right? In this case, because there was a lot of different things that needed to be done. Maybe it could have been done a little faster, but a lot of development effort. If you're not doing it in a scientific way and you just put this page out there and you just see your business hurt, now you're in a position of rollback or something else. It's not great. So we knew we wanted to A/B test. But when we built the first A/B test using client-side code injection, it took 8.5 seconds to load. Now, that's a first page load. Subsequent loads would be very fast, but that first hit was murdering us. And the A/B test was losing, not because of the design, but because of the performance. So when we took our approach with the new testing system, the revised 2.0 system that we built, where we had the variations cached at the CDN level, the test was actually faster than the control because of the way we had coded that page in a better way. And so when we looked at web page tests, our test variation was now loading in less than a second. And the faster you can be, particularly in the web world where you're trying to convert people in a pay-per-click world or SEO landing page world, this is huge. It's very important for businesses to build performant pages. Slow pages equal less money. And in this case, we saw a large conversion rate increase by doing this. So it's really about trying to learn how to work differently than you normally do. And this is not always easy as software developers for us to do. We're often seen as like a service organization inside of a company, right? There's business people and there's product people that are deciding what we're supposed to do. And sometimes you can think to yourself that, hey, as long as I write the code exactly to what they ask for, I've done a perfect job. But the reality is we're all part of the same business. Right? And so if we're not doing the best possible thing we can and we're not using everybody's brain power, then the business isn't going to be as successful as it could be. So what does working different really look like? So as we talked about before already, we know, okay, we're going to look at our data, we're going to brainstorm together, we're going to come up with a hypothesis about what the user behavior is we want to drive. But now we're also going to think about the analytics. So what is the goal that we're going for? How many people do we need? So all of this happens before you even write line 1 of your code. You're making a determination about everything that you're trying to do and accomplish as both a business and a software developer with that feature. Then you code your A/B experiment, and you start gathering your data, and then you analyze it as a group altogether. Did it work? Maybe the test failed. Why did it fail? Were user behaviors going in a different direction? Oh, people started clicking on the header more. We didn't expect that. So it's really important to analyze your data and learn after the fact. The business world refers to this as a pivot, right? So you could start doing something and going in one direction, and if it's just not working for your users, stop going in that direction and think about what you need to program to go another way. So you want to be successful, right? So this is one of my favorite quotes from a software developer, he's at Stripe currently, Patrick McKinsey. Every great developer you know got there by solving problems they were unqualified to solve until they actually did it. I think this is an important thing to think about because when we started working and doing advanced A/B testing at JustAnswer, we hadn't done it before, right? We looked at companies out there who were doing A/B testing, like the multitude of offerings I mentioned earlier, and we just could not find the right fit for us. We knew we had something unique, and we knew that we were in a unique problem, and we knew that we need to solve it. And sometimes we're just, the software developer in that given business is the best person to solve that problem. So don't be afraid to communicate with the business owners and other people in your operation about what you think would be the best thing to program to make the business successful. So use these tools to go forth and solve some business problems with A/B testing. And seriously, thank you for letting me talk with you all today. It's been a lot of fun, and I'll take questions now.
Right, I'll have the first one.
Oh, sure.
So at what size of the website would you suggest the company to start doing A/B testing? So it's obvious for big companies where they have a lot of client traffic, but what about the smaller ones?
So A/B Tasty, that was one of the ones that I referenced, they specialize in small businesses. So what'll happen is, so let's say you just don't get a lot of users, right? You're not working at this large scale where you can be optimizing for small percentages of experience, right? So what they kind of specialize in is using different algorithms to help you really make a guess. So they say, look, using normal classical statistical approaches, maybe this test, you can't tell whether this test won or not, and they basically will say, it looks like it probably did. They were basically in the service of smaller companies to use for A/B testing. Yeah. But if you look out there, there's ones, you could literally Google A/B testing platform for small business, and you'd get a lot of results.
Thank you.
Hi, thank you. It was a great speech. You talk about how A/B testing is good for the company, revenue, and everything. I assume there's a lot of good things for software engineers. Could you elaborate on that?
Sure. So in 2007, I had a startup that I was working on called Petamizzoo, and I spent 12 months writing that application code, me and my business partner. It was just two of us, and he's a marginal programmer at best, so I was doing everything. And I spent forever obsessing over that code. I mean, I pictured us selling it and the other company reviewing my code and going, oh my God, this is so beautiful. Look how great. Now, this self-documented code is amazing. And we were building it for the Windows mobile platform. And in 2008, the iPhone came out, and we had no customers. So I remember sitting on my couch going, well, that sucked. This is a waste of a year. And it really taught me to start thinking in that kind of build, measure, learn way. What I should have done is built a smaller piece of our application and get it out there and see if there were any customers, and I could have saved myself a lot of time. So one of the biggest benefits that we get as software developers from A/B testing is learning very fast if we're writing the right code or not. I hate wasting my time, and there's nothing, the worst feeling is to spend a lot of time programming something and nobody uses it, right? So.
Are there possibilities to do A/B testing in mobile?
Oh, absolutely. So there's a lot of products out there that service mobile just on their own. The way they frequently work is the mobile application will make a request, and then you'll deliver different views or different flows inside of the application. There's less expensive ways to even do that, I mean, programmatically. So we've done things with like, where we'll just basically mod a user's ID and we'll give them one experience or another, and then we'll log that data with Google Analytics. That's a very dirt cheap way to do it on mobile. But there are full systems out there for iOS and Android that are pretty easy to use.
Okay, thank you.
One of the most important things to do in a native mobile world is to make sure that you have enough users. So mobile video games do a lot of A/B testing. You'll get one menu version and another user will get a different menu version, and they'll determine who engages with the game more or longer, those kinds of things. That's a very common practice in mobile. You meant native, right? Not mobile web?
Yeah,
Okay,
yeah, I meant native.
Okay.
We have time for, I think, 2 more questions. Anyone? Okay, I'll have the last one.
All right. Thank you, everybody. Appreciate it.
Thank you.